In your packet of work for April, you're given 10 different situations. And what these 10 situations look at are real life examples of linear equations or what we can call linear functions. And what you're going to notice is that there's four pieces of information. There's a description, an equation, a table, and a graph. And in all the situations, three of those are blank and you're given one piece of information. So it's going to be your job to be using the given information to come up with the other three. So what I'm going to do is I'm going to go over four different problems, one of each type, and then that's going to leave six of them for you to do on your own. So we're going to begin with situation number one, which is about a parking garage cost. And what they give us is a description. And the description is just basically a sentence or two about the situation. And what this one says, it says, at the north parking garage, it costs $5 to bring your car into the garage, plus $2 for every hour the car is parked. So once again, these situations are about linear equations. So when I think about linear equations, the two things that come to my mind, and hopefully to your mind, are slope and y-intercept. Remember, another word for slope is constant rate. Another word for y-intercept is initial value. So when I read the description, I should be looking for those two pieces. Well, since it says as soon as we get to the parking garage, it's going to cost $5 to bring our car into the garage, that's our initial value or our y-intercept. And then it says for every hour we're parked, we're going to be charged $2. That's going to be changing every hour. That's a constant rate, or that's our slope. So now that I have my description written, or I have my description and I identify the key pieces of information, I can now write my equation. But before we do that, let's just do a quick review of what the equation will look like in case you forgot. So remember, linear equations typically in the form y equals mx plus b, which we call slope-intercept form. Once again, it's called slope-intercept form because the slope is very obvious and the intercept is very obvious when it's written in this form. The m is the slope, the b is the y-intercept. For our example, then, it would be y equals 2x plus 5, because once again, it was 2 for the slope. Every hour we're charged $2, and we're initially charged $5. So y equals 2x plus 5 would be our equation. But we don't always want to use y and x for our equations when we're talking about real life problems. Typically want to use the letters they assign to us. In this example, they use hours and cost. So it's going to be a little smarter for us to use c for cost and h for hours. So instead of using y, we're going to be using c. And instead of using x, we're going to be using h. So now our equation will look like c equals 2h plus 5. So we just change y and x with c and h. No big deal there. It's the same idea. That's still a slope-intercept form equation. Now that you have the equations, it'll be pretty easy for you to come up with the table. When you're coming up with the table, it's your job to fill out the x coordinate or the left side of your table. And that's our hours, that's our h. And since we're talking about hours, it's gonna be smart not to use decimals or fractions or crazy big numbers because we're leaving our car in the parking garage. So for me, I think it's smart to go by ones. So 0, 1, 2, 3, 4, 5. Some of you can go by twos or threes, that's fine. But anything bigger than twos or threes is probably a little too much. So now that I know what I'm gonna be plugging into my equation, I'm now ready to do the work. Some of you can do this work in your head pretty easily, but in case, let's just show you how to do the work in case you can't. So since I'm plugging in these values, I'll start with the 0 hours. For h, I'm going to plug in 0. So I'm going to have c equals 2 times 0 plus 5. And we all know that 2 times 0 is 0. And 0 plus 5 is simply 5. So we now know that our first ordered pair, or our first answer, is 0, 5. It costs $5 to initially park. Let's do one more example. I think after this example, you get the point. For 5 hours, instead of plugging in 0, this time we're going to plug in 5. And 2 times 5 gives us 10, and 10 plus 5 is 15. So it's going to cost you $15 to park for 5 hours. So we came up with another ordered pair, 5, 15. For many of us, this is easy to do because we kind of understand the situation. Initially, it's $5, and then for every hour, it's just going to be another $2. So it's going to go from 5 to 7 to 9 to 11 to 13 to 15. But just in case you want to do the work, I showed you how to do it. Now that you have the table, this should be easy for you to come up with the graph because once again, these are ordered pairs. This is the ordered pair 0, 5, 1, 7, 2, 9, and so on and so forth. So for you to graph, all you need to do is come over your scale And what I did is I chose to go by ones on my x-axis since my table went by ones. And I chose to start at 5 since my first number was 5. I chose to start at 5 on my y-axis. And then I went up by 2 since my second number was 7. So I went 5 up to 29. And then I just plotted the points. The first point was 0, 5 right here. The next point was 1, 7, then 2, 9. I then followed it with 3, 11, and so on and so forth. And then I just drew my line. And you're going to notice this line lets me come up with more values than what we initially found in the table. If I wanted to know how much it would cost at 9 hours, I can just go to 9 hours. I can go up to my graph, and I'm going to notice that it would cost me $23. If I want to know how much it would cost after 11 hours, I go to 11. I go up, I hit my graph right here, and I notice that it would cost me $27. So that's the reason we like to graph, is we like to come up with more values than we list in our table. So this is what the correct answer, or a correct answer, would look like for situation number 1. Once again, you don't need to do the same scale as me. This is just the scale I chose to do. All that matters is that you graph the points correctly and that your scale is consistent. If I go by ones, I have to consistently go by ones. I can't change it midway. I can't go 1, 2, 3, 4, 10, 15, 20. It doesn't make sense. You want to keep your scale consistent. Let's go and look at number 2, situation number 2. This one's about a monthly cell phone bill, and what they give us this time is the equation. I'm not a big fan of how the equation's written because I don't like that they use dollar signs. I don't like that they use full words instead of variables. But it's okay. We can write it that way. I'll write it a different way in a moment. Given this equation, I think it's pretty easy for me to come up with the description, because what it says is that the cost is 10 cents per text plus an initial $50. So a description I came up with is my monthly cell phone bill is a fixed charge of $50 plus 10 cents for every text I send. So once again, this is just a description I came up with. Your answer could look a lot different than this, but based on that equation, this is what I came up with. Now that I had the description and I have the equation, just like the last example, it'll be pretty easy for us to make the table. And since I'm talking about number of texts, it might be smarter for me to pick bigger numbers this time, because most of us don't text 5 times in a month or 2 times in a month. Most of us text hundreds of times a month. So I'm going to go ahead and go by 50s. I think that makes sense for me. 0, 50, all the way up to 250. And I'm going to do the same work we did at the last problem. I'm going to use my equation, but I'm going to write it a little different. I'm going to write it a little cleaner. I like to use variables, so I'm going to use C for cost and T for the number of text. And I'm going to remove the dollar signs. They're just going to get in the way. I don't need them. So I'll go and do 2 examples. After that, you kind of get the point. Let's go and look at 100 text. So when X is 100, or when T is 100, I'm going to plug in 100 for T. 10 cents times 100 will be $10, and 10 plus 50 gives me 60. So sending 100 text messages will cost you $60. Let's do one more example. Let's look at what happens if I plug in 150 text messages. Well, instead of T, I'll plug in 150. 0.10 times 150 is 15, and 15 plus 50 is 65. So sending 150 text messages will cost you $65. And you can continue plugging in for the rest, and what you should get is initially at 0, you'll be $50, and then for every 50 text messages, it's going to be additional $5. Now that we have the table, it's going to be really easy for us to come up with the graph. Once again, it's just up for you to pick the scale. My scale this time, I chose to go by 50s on the X since I went by 50s on my graph. And then for the Y, I just chose to go by 20s. I decided to do something a little outside the box, and I went by 20s. And then I just plotted my points. I had to do a little estimating here since it wasn't perfect numbers. 0 to 50 was pretty easy. 0 to 50 was perfectly halfway through 60 and 40. But the next one was a little harder. 50, 55, I had to do a little estimating there. 50, 55 was just a little bit higher than my initial point. And then I just continued that trend, and I finished by plotting all of my points, and my graph looks something like this. So once again, this will be a correct answer, or one of type of correct answer for situation number 2. Let's look at the next one, situation number 3, which looks at tree growth versus years. And this one gives us the table this time. When I'm given the table, what I like to do is just go to the graph right away. And same thing, these are ordered pairs, 0, 8, 2, 10, all the way to 20, 28. So when I plotted this, I used my scale. On my x-axis, I went by 2s, and on my y-axis, I went by 4s. So you can see I plotted the graph pretty similarly to the last two. 0, 8 was my starting point. Then 2, 10, I had to do a little estimating. 4, 12 was perfect. And then 10, 18, I had to do a little more estimating. But it was halfway between 16 and 20, so it was not really estimating. It was kind of easy to do. And then the next one was 16, 24, and finally 20, 28. Now that I have the table and I have the graph, let's go in and come up with the equation. Let's just remind you how to come up with the equation from a table. Once again, we're going to be using slope-intercept form. And coming up with the b and the m is pretty easy when you're given the table. To find the b, you just look at when x is 0, what is y? Well, when x was 0, y is 8. So b, or the y-intercept, is 8. The line crosses the y-axis as 0, 8. To find the slope, we have to use our formula. Hopefully you remember it. If you don't, it's y2 minus y1 over x2 minus x1. And you can pick any two columns in the table. I'm going to go and choose the column 2, 10 and 4, 12. So this is my x1, y1. This is my x2, y2. When I plug them into my formula, I get 12 take away 10 all over 4 take away 2. When I do the math, 12 take away 10 is 2. 4 take away 2 is 2. And 2 over 2, I can simplify that. I can divide both of those by 2, and I get 1 over 1. So my slope is simply 1 over 1. So my final answer, my final equation, will be y equals 1 over 1x plus 8. Once again, we're not going to use y and x since we're talking about years and tree height. I'm going to use some different letters. So what I decided to use was h and y. So my final equation looks like h equals y plus 8. I just got rid of the 1 over 1 because we all know it's there. We don't need to write it. So I just took it away and just wrote y plus 8. And then I had to write a description based on this information. I'm talking about a tree. It's growing after a number of years. I know that initially when I planted the tree, it's 8 feet. So my description was the tree in my yard was 8 feet tall when I planted it, or when planted, and it grows 1 foot each year. Because remember, the slope was 1 over 1. That meant for every 1 year, the tree grew 1 foot. Okay, in the final situation, we're going to be looking at situation number 8. Yes, I skipped number 4. We're going to go up to number 8. So make sure you find number 8. And this one talks about miles per gallon. And this time we're given the graph. When you're given the graph, well, the table becomes really easy to come up with because all you have to do is write the ordered pairs. This first one is 0, 0. So I just write 0, 0. The next one's 100, 4. The next one's 200, 8, and so on and so forth. Now that I have the graph and table, I'm just going to come up with the equation. This time I'll show you how to come up with the equation from the graph. Same idea, we're going to use slope-intercept form. You can find the b really easily. You just look at where did your graph hit the y-axis. Well, if I look at my y-axis, it crosses right here at 0, 0. So b is 0. To find the slope, you just look at the rise over the run, or you can actually use the equation, but using rise over run is a lot easier. Pick 2 points. It doesn't matter which 2 points you pick. Let's say I pick this first point and the second point. I just ask myself, what is the rise? How much do I increase by going up or down? Well, I go up 4, and then I have to go right 100. Yes, I'm only going up 1, but remember our scale is going by 4s. And yes, I only went right 1, but our scale is going by 100s. So what I'm doing is I'm going up 4 and right 100. I can reduce that. I can divide both by 4, and I get 1 over 25. So for every gallon of gas I use, I can drive 25 miles. Once again, I'm not going to use y and x. I'm going to use some different variables. So when I write my equation, it's going to look like G and M. I'm going to use G for gallons of gas and M for miles. And I'm going to have G equals 1 over 25 M. Yes, my equation was 1 over 25x plus 0, but you don't need that plus 0. You can get rid of it. If you write it, it's not wrong. It's just not needed. So I have G equals 1 over 25M. And now that I have my equation, my graph, and my table, all I need to do is come up with a description. Once again, this is just anything you can come up with that makes sense. It doesn't need to be the same thing I come up with. But what I decided to write was, my car uses 1 gallon of gas for every 25 miles I drive. So most of this video was review. I just want to show you one example of each. So go ahead and write down what I wrote if you want, or you can come up with your own description and your own scale for your graphs. I don't really mind if you use mine. It's now your job to come up with the other 6 on your own, but we will post solutions later on this week. Hope that helps. I know it's not the most exciting video since most of it's review. And I know a lot of it is kind of redundant and repetitive, but I thought I would just go over a lot of it as in case most of us had spring break fever and forgot most of what we learned in 8th grade.